Okay, so welcome to the afternoon, last afternoon. The two sections that are coming up now are MPContribs, so contributing to materials project, or better, like what your data could look like on materials project. That'll be the first session, and after a coffee break, Alex will talk about materials data science, a bit of matminer. And if you need any help after the workshop, these slides are on our GitHub repo in the workshop GitHub repo, and there are a few links on our Discuss forum that you could go to and find questions or ask questions. Pymatgen has the same, and any bugs or things you could actually send us pull requests or issues on our GitHub repo. All of this, again, is in our GitHub workshop repo, so you can download those slides and look at them. As for this session, there's a few things that I'll be going through. One is show you a walkthrough of MPContribs in general, like how do existing data sets look on materials project, how would that data show up on materials project, and what would the portal for these projects and data sets look like. We'll explore a bit and look around. This is mainly for you getting an idea of what contributions to materials project would look like. So what would your data be structured? What are we interested in? What kind of data are we interested in, and how would we visualize it, and maybe give you ideas of what you could do with your own data. And after that overview, there are already a few interesting data sets that I've gotten questions for on MPContribs, so we'll look at the API and learn how to retrieve that data. So if you could all go to mpcontribs.org, should be easy enough to type. I'll do that right here. So where you'll end up is basically the main public landing page with documentation. MPContribs currently has two aspects to it. One is the portal. There's a little screenshot here of things that are currently existing on the portal and the data sets that we've worked through with early adopters. And the second thing is the API that gives you access to contributed data. You can find all the documentation of how to work with the API, and also all the explanations that I'm going to go through right now, they're also on this website. So if something doesn't make sense, or if you forget after, just look up these pages, and it explains the whole setup too. So the first thing we'll do is click on this screenshot here. It'll actually take you to the portal, which is a separate satellite page to materials project. Since this is contributed data, we're basically running this as a separate satellite page, and we pull in data from this service onto our detail pages. You will need to, I've already logged into materials project here, so it's taking me to the Google social login has taken me already here, but you might be asked to log in, and I'll ask you to put up green stickers if you make it here. If it's loading a bit longer or something, maybe force a reload, but we want to make sure we get everyone here. Yeah, so the path again is go to mpcontribs.org and click on the image. While that is happening, I hope this is big enough. Yeah. I want to talk about this portal a bit. Basically, this would be, the MPContribs portal would be the direct way to see what's currently being contributed to materials project and what we've worked on. There are right now, so in that lower half, if you scroll over it, you'll see about 15 data sets that we've worked with, and each of those data sets has what I call a landing page. So, and that landing page allows you as the domain expert to show the data in a way that you find appealing to an audience. So this is really in your control. We provide defaults, and you'll notice that when I go through those landing pages that there are a lot of things are similar. In the end, what it boils down to is you giving us not only the data, but then maybe write a few lines of code to do interactive graphs, for instance, right? To show your data set with graphs that are that are important for the data set. One way this always comes in is during the process of writing a paper. So these landing pages that you see here usually are developed or set up during the paper writing process. So we are interested in all the high-level data. And authors have used those links to those landing pages in their papers to cite their data set, in a sense that, like, hey, here's a visual representation, and you can actually explore the data set here. And any future updates would probably also show up on that landing page. All right, each of those projects, right, each of those landing pages too can have multiple contributions for multiple material. When I say contributions, I mean a specific set of data for a specific material or composition on materials project. This is how Christine mentioned in her introduction slides a couple days ago, that we link up those contributions to specific materials into our materials details pages and show them there. So no contributions for us in the MP sense is always for a specific material or a specific composition. You can on this page, and I'll just briefly show it, if you use that little drop down on the upper right, you can actually see an overview of the project names, but you can also, for instance, look for band gap, and it'll actually show you a smaller list of what would have data about band gap. We'll improve this feature, but this is really only about giving you a quick sense of what data sets would be interesting. I'll dive into those landing pages later. What I want to show now is how you could browse across contributions, and that's what I call the contribution cards explorer. So it's on purpose all kept simple, so because the idea in the end is that data shows up on materials details pages. And in the introduction and the walkthrough over the website, I think you've seen the user contribution showing up on materials project. We'll get there at the end. What I want to show with the contribution cards explorer is what such a preview or what a data set for a specific material would look like on materials project. So I could go here and say, like, oh, I'm interested to see, well, what do they have in the screening inorganic photovoltaics data set, right? And I could just go and click find, and it would show me a preview of two contributions. And you might recognize these cards from the materials details pages. The elements here in these detail pages that you should know about are, one, the title links to the landing page for that specific data set. Again, we'll explore that a bit later, but also from a material detail page, this will allow you to jump to the landing page that you have designed for that data set with a graph that is interesting to you. The details button will show more than just the few data points that are in here. So if there's tables or structures or other things, that'll be on the detail page. Then there is an expandable description. So if you summarize your data set, this is what will show up on the detail page as an explanation to a first-time user, right? So I end up on a specific detail page on materials project, and I would like to know more about that data set. And this description, this short blob, should basically tell the user something about that data set. Other important aspects are the authors. I show the first author here, but if you click on et al, you'll see all the other authors. So credit is given where credit is due, I'd say. And the little footnotes here are references to the according publication. So you kind of see how we're closing this loop, basically from, MP users are giving us their data, but we're also showing them. Their goal is to show it on materials project, to expose it to our, soon to be 100,000 users. And when they browse it, they not only find your name, they not only find description of your data set, all retrievable through an API, but they also get they find your paper for it that has all the detailed explanation and the static graphs. What they should see on a landing page usually is hopefully an interactive graph of whatever is in your paper. I'm scrolling through here. So some of For this data set, I think we've done an overview graph that might be in here or not. We'll see later. But generally what people do is take like their most important graph out of their paper and make an interactive version so that people can explore it on the detail page. All right. Yes, and the last two components that I want to talk here about is the little blurb down here. So every contribution has 3 components, like hierarchical data, which is basically just key value short things, like say I have like a band gap, a corrected band gap, a dipole allowed band gap, and I'll just give the numbers, period, right? You can have tables and it can have structures, and for the tables there will be automatic interactive graphs that show whatever is in that table, like a CSV table of spectra, XAS spectra or whatever. But in the cards, in the preview, and as it shows up on the materials detail page, it'll just show those that hierarchical data. And in this case, you see like the author chose to show the SLME, which is probably explained in the description, but also then the corrected band gaps and everything. You could also up here, let's take the screening inorganic out here and say I'm interested in what a 2.9 I'm looking for. All right, this one. It's a specific MP ID. I just want to see what's in there and see there's other 2 data sets, like band gap calculated in GLLB and carrier transport for thermoelectric stuff, so like conductivity and other coefficients. So all these cards basically are driven by an API endpoint in MPContribs, and it's embeddable in other third sites. So if you're interested in your data is in MPContribs, like Materials Project will use them to show them on their detail pages, but I think you could also use our endpoint to highlight those in whatever data set landing pages you have, right? You could head towards MPContribs and say, like, just give me that card for that material. I just want to show this on my page so that I can show that it's in Materials Project. All right, let's see what contribution detail pages look like. So I'll just take this one for now. Contribution detail pages are something that is automatically generated, and you can, since you've attended this workshop, you know notebooks, and you probably recognize Jupyter notebooks when you see them. For every contribution that's in there, the MPContribs generates a static Jupyter notebook that's represented here, with all the code that's necessary to basically look at use the API. We'll do that later in our API walkthrough to get certain data and basically explore more background information of what's in there. So for instance, for this one, you can see this is the hierarchical data. It's available for 22987 for this GLLB SC project. And this part will show up on the Materials Project detail page. But there's also provenance info, like the description, the URLs that we're using to refer to certain papers. You can, in this page, you can toggle certain things. So even if you want to just see a quick overview or something, I'm not interested in any data, in any code, I can toggle things and I can jump to specific information. Let's go back and look at a different detail page. Let's say maybe ALS beamline would be nice to look at. That's something that we did with the advanced light source here at LBNL. And here you can see there's a bit more in the hierarchical data. There's also the composition and minima and maxima for the spectra. But here there's also a table, right, that shows the XAS and XMCD spectrum versus energy, and MPContribs just makes a graph of it automatically. So you could think of a contribution basically all about like, okay, here's some key value pairs of numbers that are interesting, and description, it's pretty much free form, and here are a couple tables that are important and their dependents, and please include that in Materials Project. And then MPContribs, after the data is ingested, will take care of showing it for all the projects and make it available to MP and make it browsable for our community. You can see that these graphs are all interactive. So this is called Plotly. It's a graphing library, open source graphing library that does this all for us, and this is also the library you would use for generating your own graphs on our landing pages. And again, here I could just say, okay, I don't really want to see anything. I just want to see the graphs in this contribution. So to summarize, the idea of the portal is to give you a way of, one, showing you landing pages for your own data set, so that you could point the user there and say, like, go to MPContribs portal / my project, and you'll see an overview of my data. And then if you come from the materials details page, you'll get automatically generated detail pages and interactive graphs for your contribution. So that just comes out of the box after the data set is in MPContribs. Let's look at a few data set landing pages. Let's look at the Jarvis DFT. So this is 2D data that I just wanted to explore. As I've said, data set landing pages have consist of basically summarize all contributions across this project, across all materials that have been part of this contribution. It also has an area that has an interactive graph that is specifically tailored to this contribution, and basically makes an overview of what's the important data and what would a new user want to look at. It also has a unique URL, so this one you might not be able to see, but this says Jarvis_NUS, which allows you to just share that with others and say, like, okay, here's my data. This is where you could start browsing. This is where you could start actually looking for whether that data is interesting to you or whether there's any updates. Every one of those landing pages has a table like this. So you could go and say, like, okay, I'm interested in Antimon, I think that is it, right? Not too good with the English names of elements. So it'll reduce that to that element, or let's say bismuth. So it gives me an overview of certain element or element combinations that I would be interested in. So I restrained it a bit more. Now it's 6 of those. I could also, all of the columns are sortable. So let's say, like, actually I want the biggest. Let's see whether they're, yeah. So I want the largest opt B88 van der Waals, so that's a specific potential that they've calculated the band gap for, and I can look at those numbers. What's interesting here is those are 2 projects that basically contributed similar data, and we've merged them into one to compare them. They're compared up on the top, but what those projects also have is landing pages on their own for specific contributions. So they've done all their calculations. We've taken the high-level data for MPContribs into MPContribs, and we're showing that on materials project. But you can see that for instance, Jarvis has his old landing page, whole old landing page where, like, there's more graphs and things of what they've done. So the MPContribs landing page can also be a tool to expose your own portal or expose your own page with your data. And that's what we intend it to be. We won't necessarily take everything that you possibly have, right? But we might take a high level part and then link accordingly if there's background information. Same for 2D Matpedia. They've actually just written a paper where they have this website out, and they also refer to MPContribs as something that they've exposed it to more users. All right, you can, what else? There's a little column manager, so you don't need to really, like I say, I'm not interested in certain things. I want to switch, or some contributions have really a lot of data in there, so sometimes this can get a bit wide, but it comes with the manager to just reduce it to things that I find interesting. And since there can be structures in contributions, and there was a structure in here, there's links generated that would just give you the CIF directly. Let's try this again. There you go. So you might recognize this as a CIF from Pymatgen to download the structure. So I think a good example here, a very simple example, is actually from a couple workshops ago. We had I think his name is Mark Esters, but he basically just contributed only one structure, right? That's shown here, and that structure is part of MP. It's he describes why this is maybe calculated a bit better or differently, and we've referenced the paper for it, and that's it. So it can be as simple as that. All right, cool. I want to highlight one other landing page. That's probably the most advanced of all of them. He's sitting right there. So Joshua from the German NASA, from the German Aerospace Center, has worked a lot on getting his data on Materials Project. And again, I think you can see the same elements here. They're at the very bottom of this. There's the actual table that will happen for any contribution, and some high-level data in terms of tolerance factor and whether there is experimental and theoretical data available, the compositions that they're for, and the which solid solution system that is for. So also here you could go and say, like, actually I only want this part, and it'll just show you what MPIDs these contributions are for and whether there is actually something for this compositional system. But on top of it, the interactive part of this landing page actually is pretty involved, and Joshua decided to show isographs and calculate isographs for all those contributions and the data that he has in. Some of it is pre-calculated at certain x values, so it's actually we're actually able to disseminate it on the fly and do calculations. For the isographs, for instance, you could there's sliders that you could click around and look at specific different conditions and look how those entropies and other parameters change when you change your process conditions. If you're interested, I'll just refer you to Joshua. He knows a lot more about this if you actually want to talk physics. I just want to show the interface. And you could select certain materials, and it'll show the according data for it. So all of this is something that we work with him to actually disseminate that data a bit more in detail. Same for an energy analysis. This one is actually pretty heavy because it involves calculating quite a few things on the fly. We have pre-calculated so that you can set certain settings and look at rankings of materials for certain conditions here in different units and stuff. So it can be as fancy as this. You can invest as much as you want, but it can also only be a table. Yeah.
I'm wondering about the MPID.
Yeah.
Is that like matched, and if it doesn't exist, it gets a new?
That is a very good question. Yes, I haven't mentioned that. So what happens when you contribute, and that's probably a side discussion, is we'll look for a you either give us an identifier that you think this should belong to. This is sometimes depending on the physics, right? So you could say, like, hey, I've got this this host. Let me show you an example for host solid situations, right? Let's go here. Sorry. So for dilute solid diffusion, you could have certain hosts and certain solids, right? And you could say, like, okay, I want these two numbers, diffusion coefficient and Q. I want this as part of atrium, but they actually decided, no, this is a set of solids for one specific element, iridium. So all of those contributions are part of MP 101, right? Because it makes physically more sense. So this is one way to solve it. Or you have a structure that you calculated that matches MP. I'll get to your question. And then this way, we'll, like, if you add it to it, you can basically, through MPContribs, there's ways that you could add a structure to a contribution. It'll automatically match it against MP and suggest that this should be the MP ID, or you choose your own and you enforce that it actually fits the other one. I'm keeping it flexible because I think the domain expert knows best which structure he wants to choose, and most are actually they work with Materials Project and say, like, okay, this structure belongs to this one, this MP, and this MP, and I'll let that link stand that way, right? It might happen later down the road that we change things, or that then it's our responsibility to basically reconfigure those links. It can also happen that it changes on your end, right? You're like, yeah, that structure was wrong and it was the wrong MP ID, and then we just update it. That just means that contribution moves from one detail page to another detail page.
And on that main page, it refers, there is an external contribution, but
Yes, I'll show you. I'll close that loop. I'll close that loop. I just want to show these aspects first. Any other questions so far? Still looking good. Okay. Yes, that's actually, so you're actually bringing me to right my next bullet point. So I've shown you all the contributions and MPContribs from the portal side, so from a view of probably a contributor. This is a more contributor-driven view of MPContribs in the sense that, hey, where's my data set? Where can I go that I can just quickly find my data set and what's in it? And where can I send collaborators? The way that Materials Project users get to it is usually through Materials Project, right? So one way we could actually find something and say, go for the exercise, and you could do it with any material or compositional system that you're interested in. I'll do it for bismuth, this one, right? Because there is a few in there for that. So if I search for that compositional system, is that the right one? Yes. Actually, hold on. Does that make a difference? It shouldn't. Well, let's look at this one. See what happens. So yeah, so just choose your elements or your chemical system of your choice. Select one out of the table, and if there is contributions in there, and now we're coming to your question, you'll see that little tab on top of the detail page, right? So if we click on that, this one has actually has data on carrier transport, and I think since I've given the introduction of what contribution cards are and how contributions are organized on the MPContribs side, you'll recognize this part, right? So it's literally only an embed. Like we take whatever is on the other side, whatever we've organized with the domain expert, and show it up here. Also here, it's the same thing. Like a user could go in. I want to see the descriptions. I want to see the other authors. I want to go to the according landing page for that data set, right? And it takes me to the actual carrier transport data set and that table, right? Let's see. Another one that I always find interesting and test is MP22987. That one actually has 4 different ones, right? So if you added your data set to MPContribs or to Materials Project, you have one of these cards showing up here, and you'd be in charge of what data would be shown. For instance, we've looked at the band gaps, and we've seen that there's Kohn-Sham and quasi-particle band gaps in there that we're showing. I've briefly shown the carrier transport data set that has all these average values in it at certain temperatures and doping levels. Then there's the Jarvis DFD, the exfoliation energies that have been contributed. There are from 2 different projects where we actually link out to the according one. So this is also something interesting for users to say, like, yeah, I actually have it. I just want MP users to see it. So make it show up here. Right? And if it's really only this part of the data, say like I have one interesting number and I have a link, perfect. Doesn't have to be more, right? But only the things that are actually in MPContribs as a data set are then later disseminated through the API, of course, right? I can't like integrate with any API that's out there. So you'd have to, in the process of writing a paper, you'd have to find a middle ground of what's reasonable to disseminate to the public and what will I just provide as files or something in the background. Raw images from instruments on beamlines is not something that we'll take. Just a saying. We get those questions. And then I think this is, another data set. So, all right. I think that's all I wanted to show for the contributions. Any questions so far about this whole setup? I wanted to make sure that everybody that everybody gets a chance to browse around, find his way around, know what contributions are and what they would look like. I think the important takeaway here is that it should help you think about what your data set could be on MP, right? And right now, we're in a stage where we've done this with 15 other data sets, and we've learned a lot from it. But as of now, if you have an idea of whether a data set could be interesting, what it would look like, you'd reach out to me, and I'll point you to say the next generation of how you could actually do this yourself and put it up on MP, right? But right now it's still a stage where we where I need to look at data sets for a bit to kind of make sure that we're not becoming just a Dropbox for data, right? But we're moving towards on the ingestion side of MPContribs, we're moving towards using notebooks, preparing contributions through notebooks like in Jupyter as you've done, and then allowing you to push up to your own data sets. The whole thing is designed so that you should be able to update your own stuff further down the road. It's not, we don't have the manpower to just maintain this all the time. So the domain expert that actually contributes to data will play a very important role in maintaining it and forward. But we'll maintain the infrastructure, we'll keep it running, we'll keep the data up, we'll keep the website up, we'll integrate it with MP, we'll make it disseminate, we'll make it programmatically retrievable through the API. So that's all taken care of. What you have to think about is the data correct and is it what I want? All right. Okay, let's go to back to our Jupyter Hub Matmgen 5. So if you go to, if you go back here, we'll go through a little tutorial with one of the data sets of how to retrieve the data that you've seen. I've had questions yesterday about that screening inorganic photovoltaics data set. So that's something you could try it with. I'll show it a bit with Joshua's data set, and but it works all the same. Okay. So if you're here, let's go to MPContribs and go on the. You can look at the API tutorial, but I'll actually just start a new notebook before we start typing. And before we start typing here, I just want to make sure that you guys get here. I want to show a bit more where the API lives and how you can actually try it out without being in a notebook. So you could go back to MPContribs.org where all the documentation is. I've referred to the API entry in the documentation that basically shows you how to do that in Python and use Python to retrieve data. There's also notebooks on Binder that you could use that have examples. But what I want to show is the actual API. So if you click on that MPContribs API link, or you go to api.mpcontribs.org, you should be seeing this. It looks a bit technical, don't worry about it. But what I want to show here is just a couple of sample requests that you could play around with. We've talked about those components. We've talked about that there's multiple projects with landing pages. There is projects that have an overview table and an overview graph. We've talked about structures in contributions, and this is an internal one for the notebooks, the contribution detail pages. We've talked about tables being in contributions, so you can retrieve those too. And then the general contributions endpoint is basically pulling this all together, pulling structures and tables and referencing those if you want to look around. So the one thing that I want to do here, just as a precursor to actually writing code, is go through a few requests and responses to the API. So if you let's see, do I have the portal still up? On your portal dashboard, so if you're on the MPContribs portal, there's a dashboard link in the upper right. It's the same principle as with the main MP site. There's an API key that you use for it. We will eventually integrate those, but for now, those are it's a separate satellite page with their own API keys. So you would take that API key, copy it from there, and then go back to this API page, click on Authorize, put in your API key, and click on authorize. What this will do is allow you to actually test out these endpoints right here. For instance, we could, I'll give you 30 seconds to get here. So get your API key from the MPContribs portal dashboard and put it into authorize on this page. So for instance, what you could do is let's look at the projects, right? It's just the project's endpoint that lets you search and mask out certain keys, but I really only want to try this out. So I'll click on try it out and just hit execute. And that'll give me an example response of things that are in there, right? So without actually like writing code or anything, I just want to take you that step further to, hey, okay, I've seen all that data on Materials project and on the portal. What would it look like if I actually want to do this programmatically? And this is a way to test it out, get a feeling for the API before you dive into Python and writing API code. Here too, you could say like actually one way we do this is we're not returning everything with every request. So you actually have to ask for stuff. That's the same in Materials project. When you remember a session, you actually have to give a projection and ask for certain things that you want. Otherwise, you're not getting anything returned. So here, I actually ask for the project and the title. I also want the description, and I'll execute. And it'll show me all the projects and the descriptions for it. There's a little download button. If that's all you need, you could already just do that, right? So sometimes working with an API could be enough through this, because you're actually only looking for a small JSON blob of contributions, and you would want to download that. We could try out another one. So let's close the projects and go to contributions. Let's try this one out, see what happens. There's a lot more options here that you can use. Again, I would just execute this. What it'll do is give me the first 20 contributions that it finds. So now you see there's a certain contribution ID for a certain MP ID and a certain project. So those are three things that always belong together to a certain extent, right? We've talked about the fact that a contribution to a material will show up on Materials project, and it'll always belong to a certain data set. And if we wanted to actually see more, we could actually, this endpoint, I won't go through all of it, but you could actually use this endpoint to look for specific identifiers or look for specific projects. You could actually substring search in the identifier, say like everything that has MP10. That's sometimes important if you don't really know which one it is, but you know parts of it. You can add and mask, and you can also filter. So for the filter part, we'll do that in the Python session in a bit. What I want to do now is just drill one level deeper and just take one of these contribution IDs here, just copy it, take any, and use it in this specific get endpoint that does single contributions. So here, all this does is actually download that entire contribution. So if I took this with its according ID and execute, it'll give me that whole thing, right? So, and you could look at the structure and the responses that way. So this is for MP2715. Maybe blow this up a bit. And you see that there's stuff in content.data, right? This is where actually like the hierarchical data lives. There's the cone sham, the quasi-particle band gaps, the CICSD, that stuff that this contributor decided to put in. If there was tables or other things, they would also show up in content.tables, content.structures, and so on. All right, let's do some coding. Anybody have any questions so far, or problems, or? All right. All right, let's go back here and do some coding. I hope this should be big enough. There is an MPContribs Python client that lets you do the things that we just did on this API side. through code, and it'll give you functions to just retrieve data and work with it in your code. The way it works with MPContribs is basically use the MPContribs client. So we'll just go from mpcontribs.client. Also type right. Import load client. So this is like MP-Rester. What I would do here is we also need your API key. So we've just done this exercise. I think you know that you go to your dashboard on the portal, get your key, just put it here, and then we'll initiate it. Very simple to how MP-Rester works, just that the names are a bit different. But all I'll do is load a client to this API with my key. So client now gives me all the functions that this API provides. It's a dynamic client. It's a bit different than with our main MP API. So the things that this client provides, so like Jimmy has talked about that dir function, it'll load from a specific specification file. It'll load that API specifications and generate a Python client on the fly, right? So for instance, in the case of the MPContribs API, those are the endpoints that you just remember from the API site. So there's contributions, notebooks, projects, structures, tables, right? So if I keep dealing and say like, okay, what does client.projects do? Well, it gives me get entries, get entry, get graph, get table, get columns. So there's convenience function or functions for every endpoint that I've listed. So every endpoint here, every URL here has its according parallel name in the MPContribs client. So we could, for instance, let's get some project info and say we were interested in the Redox Thermo CSP project. That's Joshua Wheaton's data set from the DLR. We could replace this with anything else that we're interested in, and we could go through an extra data set if there's time. For now, I'm only interested in the provenance information, so any project info about this data set, right? So, and all the project info is in client.projects. So you could do client.projects get entry and tell it to use this project, right? Use Redox Thermo CSP. So if you do that, it'll basically set up a request. It hasn't at this point actually sent a request yet. I've just checked whether my syntax is okay and whether my request would actually fail or complain because it doesn't have the right parameters in the function or something. To actually send a request, you just ask for the response and the result. That's a bit a special case for dynamically generated API clients. So I don't have to write that client myself all the time. I can just give it the specifications of the API and the Python client loads it dynamically. So I'm adhering to whatever Bravado decided to write as an interface, but I'm saving myself a lot of work in terms of writing Python clients, right? So if you do that and run this, it'll send a request and you'll get that same information back that we've seen like from 3 different avenues now. So for Joshua's, it's all the authors that were involved with that data set. There's a description of what's in the data. There's his energy and environmental science paper that refers to this data set and to that landing page. And there could be other information if necessary. There's we could check out whether there's actually something in there. So say this is what's returned by default. You see that project and other is none. Let's say I'm only interested in a certain subpart. That's what we would use a mask for. I'm just reformatting this a bit. So as a mask, I could say, which is the same as a projection in MP-Rester, say like give me the description give me the URLs, and give me whatever is in other. Right. So this becomes a bit more in the sense that title and authors are gone now because I already know that. The description is still there. The URLs are still there. But there's extra information in other actually that describes some subparts of that data set. For instance, in Joshua's case, there's experimental data and there's theoretical data that he chose to describe a bit extra. That data has a spot on the landing page where it'll show up automatically. So whatever is in other, I would actually take and show on there too. All right. Let's see whether we can get an overview of, close this, hide this, no, doesn't matter. Let's see whether we can get an overview of a project or of the data that is in this project. And we're just playing around with the data, so we try to get a bit of a better overview. That's what the table endpoint is for. So there's a get table function that I can use, and I could say, for instance, all right, let's do client.projects get the table for this project. That looks okay. Let's actually send the response. And what it'll do is basically retrieve that overview table that you've seen on the landing page. It'll retrieve it and show it in the notebook. Yes, so I'll just run this. What you do when you run this is the same as above. You just get the naked API response. Any helper, Donnie? Somebody help, please. All right.
I'm getting in a 403 forbidden error. Me too.
Did you enter your API key from the MPContribs portal or from the materials project? Yeah, use the MPContribs portal API, please. Key. Yeah, there's a different ones. As I said, the MPContribs portal is a separate satellite page, so you'd have to go on. You have to land here and use this one. It's a longer technological discussion whether we integrate those in the future or not, but I won't bother you with it. Yep. Oh yeah. I can reiterate. Yeah, the same here, right? If you want to use this, make sure you go and authorize and hit and put your API key in here, right? Because if you log out, it'll just give you 403s, or if it's the wrong API key, it gives you 403s. Yeah. Any question? Yeah.
Where can we find the MPContribs?
Go to mpcontribs.org. I'll do it again. All right. So if you start from the beginning, mpcontribs.org, you'll land here. Click on that image. You should end up here. Maybe, yeah. And there's in the upper right corner, there's a dashboard. Right? Might have missed. And if you click on it, you'll see your key.
I don't have the same.
You don't? Where you at? Yeah, click on the image. Click on the image. The big screenshot in the middle of the page. Yeah, so let's go back. Just click on this. So I'll wait a minute for people to catch up. So if you found your right key, put it in here and execute the cells again. So where I left off is we want to get an overview table of this project. And we're using the get table function for it. If you just take the client and ask for the response and the result, you'll get like the total count, and you'll get a list of items, which is basically every entry in that default table, right? So if you went back to to that landing page for that data set, you would see all these values show up in that table. I just want to make this show up a bit nicer in the Jupyter Hub, in the Jupyter Notebook. So I'll assign this to data, and I'll get a class or get a component from MPContribs, from the MPContribs IO module that allows me to just show this a bit nicer and explore it the same way that it is on the landing page. So we're going to mpcontribs.io.core.components.tabular data, and we're getting table from it. So all I have to do now is, all right, I know there is the items in that data. I want this for a certain project, and I want this, I want it to use my API key. I'll explain why. So table would work without the API key, but it would just take whatever is in that data dictionary. For it to work interactively like it does on the landing page, it needs to send extra requests, pagination requests, sorting requests to the API. So I'm basically giving that table constructor my API key so you can do that. So if you execute this, you should see this show up. And you probably recognize all of it from the landing page. So the reason I've implemented this is because I think it's valuable to have that same representation all across the entry points a user could look at. And people know this from the landing pages, right? So you could, here too, you could actually now say, okay, I only want to see MG1. It'll actually in your notebook send a request and say like, okay, those are MP IDs that have that formula. I could say I'm not interested. I don't want to see any of the composition. I don't want to see the last updated. I don't want to see closest. All right, this looks better because I just want to explore divide temperatures, for instance, or tolerance factors. Let's see whether we can put the tolerance factor in, but take the active material out. And what we can do here is just, for instance, let's clear the search. Let's say I'm interested in to see like, okay, which ones have experimental and theoretical data. So I can sort on it, look for that, or I can sort on tolerance factor and see like, oh, okay, this is a material with the smallest tolerance factor, and a tolerance factor translate into specific structure type. Correct? Is that sort of correct?
Yeah. If it's close to 1, then it's the most stable.
Correct. So it's actually a valid question to ask. How close to 1 am I? Or how far away from it? So I'll use that to actually do some queries on that data, but this table overview basically reproduces whatever is on the landing page and gives you a table to browse through things and see things live. All right, let's see. Let's use this data items that we had and look at that first row. Which just gives us these columns and cells for it, and I'm interested in this contribution. So every contribution has a specific ID, and I'll use that ID to just get a specific contribution from the API. So what I could do is again use the contributions function. So we're switching now from projects to contributions. I've looked at the project. I've seen what's there. I'm interested in actual contributions, and I'm looking at a specific entry that I have the contribution ID for, right? So that would look like this. Let's just see. Looks like my format is good. Send the response and get the result. And what this will do actually for a specific contribution, and then there's data sets where there's only one in there, so all you might ever have to do is this and just get it, right? And it'll just, for this contribution and in this data set, in this case, there's not only content.data with the tolerance factor, you see it's in there, but there's also a lot of tables that are referenced here with their table identifiers to the table endpoint. So if I wanted specific tables, we'll do it in a second, I could retrieve those too. Let's look at the hierarchical data for this. So I want to look at content.data and maybe look at that a bit better than just in that format. This is really only to show what components and teach what components MPContribs has. So I call that part hierarchical data, and I could just ask it to show me whatever is in that data entry, right? Oops. Sorry, not content. So I forgot to give this a variable, and then I'll just do this, and basically it's also same principle. It gives you a way of like, okay, this is what it looks like on Materials Project. This is also what it looks like on in my notebook, right? So different ways of exploring the same things. And what I want to do next is look at one of those tables that are in this contribution. So I can. It's all the contribution content is always in the content subkeys, and there's tables in it. So if you looked at that, you get all these references to tables, ID tables that are part of this contribution. If you just use the get entry endpoint for contributions, it won't just load everything, because this can be big and slow. So there's always, with every response, I'm trying to keep the response fast, but give you ways of drilling deeper. And what I want to do is look at that first one and use the tables endpoint now. So it's pretty straightforward. Same way with get an entry of a table with a specific ID. So now I call it TID for table ID, and I'll actually want to look at what this data looks like. So here I get the response from the API that tells me two things. Well, all the main information on project, which ID it belongs to, what the name of this table is. I think Joshua will definitely recognize what this all means. And there is two aspects here. One is columns for that table, and then all the data for that table. And for people that have worked with pandas, they probably recognize this format. This is all Panda style. So if you're interested in how to use that data, you could just forward this into a data frame and it'll work. That's basically what I'm gonna do next. So let's take this data, assign it to something, and use the table component from the table component that we imported earlier, and import it from and use that data for it. So right now I would just want to show a table the same way that I did earlier. The MPContribs table just inherits from the data frame, so everything you can do with a data frame you can do with a table here. It just has extra visualization on top that makes all this possible. And it sends the requests if needed. If it's pagination, you see like these tables can be long, right? And when we go and to keep the responses fast and not download too much data at once that people are not interested, while also allowing them to explore the data set, it allows for secondary API requests that just do pagination and look at the data, right? So one reason I have all these components is now that you could actually take the last component of the I/O library. That's the graphical component, so it's in GData, and I just called it plot. So if you have a table that comes from MPContribs or is a data frame, basically all I'm doing here is generate a plot from that table. And what you'll see happening is two things. One, it'll just from that table it generate a Plotly graph. I've talked about Plotly before. It's an open source graphing library that allows you to generate interactive graphs. So if you hover over this, or you can switch certain things off, look at certain data. Everything that's in the table is just shown here by default, but it allows you to actually zoom in and explore. And the second thing that you saw happening here is that it first loaded whatever was in our local dictionary, but it sent a secondary request, a second API request to get all the data and make this graph. So there is there is extra logic in the MPContribs component that makes it a bit easier to talk to the MPContribs API and retrieve data as necessary. Not everything by default and not everything at once. All right, we have 2 things more, and I'm actually pretty well in time. So we'll do 2 things more. One, query by materials identifier. So let's look at that data, say, and see what data for a certain MPID is in, whether there is data for a certain MPID in this data set, and then we'll filter by a certain value, and we'll wrap it up after. So let's say there's 2 MPIDs that we're interested in. So identifiers, let's say I'm interested in MP 1077669, and we're interested in MP 554938. So those are 2 MPIDs that I found in materials project, or that I know that I work with a lot, and I want to see what's in there. Might have not mentioned it with the question before, but if a certain material that you want to assign a contribution to doesn't exist in materials project, there is MP-complete that you could suggest structures to materials project. We would take that suggestion, calculate it, give it an MPID, and you can assign after. The idea is with MPContribs that the materials exist in materials project if you have a specific, otherwise it's just floating and dangling without any association. Might not have made that clear before. But the idea, it's if most of the materials should hopefully exist, but also in Joshua's case, it was the case that we actually ran a bunch of materials first to get MPIDs for us. That's why those are so high, and then assigned the contributions to it. So let's look at those 2 identifiers. Let's also set a mask. Say I only want what identifier that actually is, and I want the formula for it, which is in data for this data set. And I want the tolerance factor. Right. So you remember that dot notation in terms of MongoDB nested fields. Say those are the 3 things that I actually want, and then I'll go and send my request to the contributions. I'm using the getEntries function that gives me that can search across contributions. And one thing that's in there is, again, you can, for all of this, you can, hold on, does it work? Should work. Yeah. So for all of this, if you're in that function, you can still use Shift-Tab and others to get information, right? So I've been just going over and used whatever flags I wanted and whatever keywords I wanted. But if you wanted information from within the notebook, you can use Shift-Tab and actually read what you're looking for, like here. And those things reflect exactly what you've seen on the API page. So if you browse it on the API page, it'll also be here, since the Python client is generated dynamically, right? It'll always be in sync. And the things that you could do here are projects, identifiers, maybe a substring to search for identifiers. You can give it the page a mask, and you can filter. And the filter is something that we'll do in a second. So for now, I just want to know, I only want to look for those 2 identifiers. And yeah, that looks fine. Let's send the request and actually ask for the result. And this is what it's going to give me back. So I looked for an identifier, specific ones, and those are contributions to those 2 identifiers across all projects. It just happens to be Redux Thermal CSP. So I could do a test here and say, actually, what will happen if I do 987? Yeah. So remember the example from early on where we went to the 22987 page, and there were 4 contributions on that detail page. Those are those 4 contributions that were for different projects and different data sets. All right. So that's how you look for specific MPIDs across data sets. And the last thing we'll do is that's actually perfect because I'm until 2:15, right? I'm 215, right? I thought it was 215. But doesn't matter either way. That's okay. So yeah, the last thing I want to do is actually query by values and apply a filter. And this part, of course, is project specific, depending on what data is in a certain project. So, for instance, in the Redux Thermo CSP data set from Joshua, we could I would just define some filters that I could give to the contributions endpoint. A very simple one would be, well, I want the formula to only contain this, right? So the way it works is the first part before the underscore is the field that you're querying for. The contains is an operator, a MongoDB operator that we've discussed before. This can be greater than, larger than, equal, whatever. And then after is this number or string what you're looking for. So I'll define it that way first. Let's start simple. And I'll give this to the contributions, get entries, so the same function. I'm looking across contributions now. The projects that I'm interested in is only this one, right? So I can give it a list of projects here if I want to. Let me just reformat this a bit. If I have multiple projects in mind, I can actually look across them or give none of them if I want to look everywhere. But the formula key might not be in every contribution, so I might not find this, right? So with the filters, we're getting into a territory where each data set might have their specific keys in the hierarchical data, and that's what you're looking for. And you should be able to, like we did before, explore the data set and figure out what's in there. The mask, again, I'm going to use the same as up here. I only want the formula and the tolerance factor, so I'm going to use the same mask. And now, instead of just running this across all contributions, I'm actually giving it filters, and the filters I've defined in this list before. Let's see what happens. Yeah, this is a well-formatted request. So let's actually send the request and get the result. And you can see here too that if you scroll across those formulae, this should this as are in here. You see that those are only ones that have actually as are in their formula. We could be a bit more specific and say, like, well, the way he defined his compositions is with fractionals in there, so I could actually reduce it a bit more. And what it does is just respond with the tolerance factor in here, the formula, and everything else is none because I haven't requested it, right? So let's be a bit more specific and get back to the example that we discussed before. Where am I?
You can feel free to enter if you want. We can have Alex do his first unit.
Yeah, that'd be great. That'd be great. So just to make this a bit more meaningful query now is, well, we've learned that the tolerance factor tells me something about the structure, so I want to see things that are close to 1. And I'm going to say, well, let's look tolerance factor greater than 0.995. And I still want to look for all elements, all SRs. So let's look also for a tolerance factor that is less than 1. So the query language is a bit different here for technical reasons, but it's equally easy to understand, I feel. You get the field first and then the operator second, and give it the value that you want to query on. And then if I reran that, you'll see that the tolerance factor for formula that are interesting to me is actually the ones that I like. So 995, 996. You can see how we're going up, and we actually shouldn't go past 1. Yeah. So those. Let's see how many there are. If I assigned this to a variable and actually looked at the length of it, 22. So I think there are about 256 or something in there, materials or structures, and 22 out of those fall in this window. All right. Any questions so far? All I wanted to do here was basically introduce you to the API. You can always look at the GitHub repo for MPContribs. There's a binder directory in it. Let's change this. So you could look at this and find more notebooks for other data sets. There's a notebook for screening inorganic PV in there. I think I've done one for carrier transport, but you'll see the same patterns repeat. It's just data set dependent. And please, if there's anything, if you work with the API and you feel like, okay, I can't run a certain query or something, reach out to me. I'll try to make it work, and I definitely want to improve the API in a way that it works with across data sets, but also well for people that are interested in specific data sets. It's somewhat of a trade-off sometimes, what I can or cannot do. All right, I won't do this, but I'll just mention, because we've done this before, if you wanted to now download that data, there's the Monty serialization, right? So you would just import. You might remember this from Sam's class. He imported like the dumpfm function, and you could just give that contribs object or whatever you generate from the API to dumpfm and download it. In this case, in your local container, and use the Jupyter Hub to download it to your local machine or something. So this way, you won't have to actually install anything. You can just work on our Jupyter Hub or in our environment, and then when you're done with your data and you have what you need, download it and do offline whatever you want. That's usually the process. All right, that'll be it. Any questions before we move on to Alex? Yes?
So if I would plan to submission my database to Contribs, what would be my first?
So your first contact would right now still be me.
Yeah, okay.
And that's great. I think within the next couple of months, I'll release a way that you can do more and more yourself. We've done that before. I've done that with those 15 people. I've just kept it behind doors. It has worked on a trust principle right now, right? Because you're writing to a centralized database where everybody kind of does things. So I'll set this up in the next, hopefully, couple of months that also allows certain permissions to be set, who can work on your data set as opposed to others, who can change things. It'll be notebook based. There is code in the MPContribs library already that allows you to prepare contributions. So you could go in and look, and maybe that's the one second step that I would recommend is if you go to the MPContribs GitHub repo, you could browse around in the in MPContribs users, which are all the people that contributed. And if you go into MPContribs users, you see all these projects, and the way it has worked in the past, and the way I want to make this a bit easier is what would be a good example? Let's take DTU. I think that would be good. So DTU, for instance, has a pre-submission file here, right? And basically what it does is just define a run function, right? That takes your input. Here the input is just a remote database. So, or it can be a JSON file that you uploaded to our Jupyter Hub. Again, it's not like you can upload 50 gigabyte with a web request, right, or an HTTP request, but usually up to 5 megabyte or something should be okay. So people, what you usually do is zip your data up. You know how it's kind of formatted and stuff, and then you would use this to basically go over them, pull out what you need, and then the two important functions, for instance, like the things that are already in there is the MPContribs IO library has an MP file, and you would add data to that MP file, and then you can take that object and just push it to the MPContribs API. That's the idea, right? So you would prepare your data with adding hierarchical data. It has an add data table. It has an add structure. The add structure will test against materials project and see what other materials are there. It'll assign an MP ID if necessary. Or you can give it the identifier of what you want to add it to. So that the library, the Python library is there. I just have to make this so that people can actually execute this, and I can write documentation for it. Before that, it's kind of hard to get it to people. But yeah, if you're, I think the very, very first step would be browsing existing data sets, look at what is out there, and maybe tell me, hey, this is very similar to what I would like to do. And then we can get you started that way. And the best spot to start, or the best time, is probably like 3-4 months before you submit a paper. So if you're in the paper writing stage, you'll hear me ask a lot about, okay, can I get the data that you need to make the graphs in your paper? That's the data I want. Everything else, probably not. And it's usually a good stage because that's when people can cite their data on materials project, or you can prepare it interactively, and you're working with the same graphs, and it's still in the mind and fresh. So, all right. Anything else? Thank you very much. I'm gonna give to Alex.